Modeling. Well, what happens when instead of giving us a vertex, they actually give us two zeros on a point? Or if from the word problem I can tell where the thing hit the floor, or I just got zeros in some way on a point. Well, I'm going to use factored form instead. So my factored form equation looks like this. And I know that I have, a point. My point would be x and y. Therefore, if my y is 7, I'll replace my y with 7. If my x is 5, I will replace it. And notice that there's two spots where x goes, so 5 is going to appear twice. Then I have my two zeros. I'm going to call, let's say that this one's s. So my minus 4 is x minus 4, which would end up looking like plus 4. And then I have that my other s, let's call this one t, is 6. So x minus 6. And there you go. We have all the information that we wanted except for the a value. Now we have one equation, one unknown. We can isolate for a. Notice that I plotted my two zeros, minus 4 and minus 6, and then that point 5 and 7. Looks like the parabola opens down. So when I get my a value, I should check that is a negative value. So this one's not too bad. The 7 stays here. This bracket is 9. This bracket is minus 1. Minus 1 times 9 gives me minus 9a. And therefore now we need to divide both sides by minus 9. Divided by minus 9, divided by minus 9. And then we can see that the a is actually negative 7 over 9, which is not necessarily a very nice a value, but it is what it is. Now that's my a value, but I have to give the equation. Modeling means finding the equation that would describe the system. So I have to go ahead one more step and say that y is equal to negative 7 over 9, x plus 4, and x minus 6. And this equation gives us the shape, and it gives us the two zeros, and models every point along that parabola. That's why the y and the x need to stay as y and x, because every single point will have a different value, but the zeros will stay the same and the shape will stay the same.